Hi guys, and welcome to this Indiegogo campaign video for my documentary They Call Us Channelers. My name's Kevin Moore, and since October 2008, whilst at university, I started hosting the chat show called The Moore Show on YouTube. I've been interviewing people from across the world on the subjects of consciousness, the paranormal and spirituality. Now, covering these subjects and interviewing so many researchers in these fields has shifted my understanding and truth. But the biggest change I went through was in January 2015 when I started to channel. Now, channeling to me is just a form of energy exchange. It's an ability to bring in teaching information into this present moment right now, enabling us all to bring more understanding and peace to our lives. So in this documentary, I'll be traveling across the world meeting channelers from the UK, America, parts of Europe, Dubai, Australia and Asia. Now, my intentions for this documentary is to showcase that we all have this ability to tap into our more natural state of who we already are, just as writers, artists, poets and scientists naturally do all the time, and expanding the word channeling, and also not forgetting just how important the human experience is as well. Now, I plan to dive really deep with the channelers, to ask the channelers the questions they've never been asked before, to show people that there potentially is a reality that's never been brought through before, and by asking these deep questions, it will only bring us back more into the present moment. So we've already gone into production for the documentary, as we've had a few private donors go beyond the call of duty, which has enabled me to buy the camera equipment and film channelers across some parts of the UK and Europe. Now, we're looking to raise $15,000, as this will pay for the international travel costs, post-production, distribution and also promoting the film at film festivals next year. So I really need your help, guys, in making this a reality. Now, your energy exchange will mean so much. Remember, we're all in this together. This is oneness at its best, as this will really help people expand their reality even further and help people make sense of why things are the way they are. So if you feel drawn to help out, then in the description of this video you'll see the links to our Indiegogo campaign, and no matter what you can donate, all donations receive a digital copy of the documentary before the general public when it's released next year, and also a thanks in the credits for the video. So I just want to say from the bottom of my heart, and the transparency that I'm showing in this video, just thank you so much. This has been a year's worth of my journey to get to this point now, and it was September 2016 when the idea for the documentary came to me. And your donation, your help, just even sharing this video means so much to me. So much love, thank you for watching, and we'll catch up with you on an update soon. Broadcasting from the UK and across the world online, you're now watching The Moore Show, and I'm your host, Kevin Moore. Now, for the next hour, I'll be covering subjects that will open up your mind and provide you with information you may have never heard before. Now, on today's show, I'm about to be joined by my guest, Chris Impey. Now, Chris is a University Distinguished Professor at the University of Arizona in the United States. His research interests center in observational cosmology, gravitational lensing, and the evolution and structure of galaxies. Now, he's a past vice president of the American Astronomical Society and has served on its executive council and its astronomy educational board. Now, his web design and curriculum projects have been supported by both NASA and the National Science Foundation. Now, he joins me today to discuss his many books and research. Chris Impey, welcome to the show.
Thanks, good to be with you.
Oh, it's so good to have you on, sir. It is so good to have you on. Wow, what a mind you've got. I love your books. I really do. You've done so many great books. I think where we're going to start here is just at the beginning, just with all this. Just what got you into astrology as well.
Well, you know, astronomers come from two ways, usually two ways up. One is telescopes little telescopes as a little kid, trading up to bigger ones. But despite my accent, I grew up in the UK. Didn't have skies. You know, I was in London a lot of my childhood, and then New York. And so I never had a sky. So I didn't become an astronomer because I had a nice sky to look at. The other way is through physics, and because astronomy and astrophysics are really just projecting physics and how the universe works outwards rather than inwards into the interior of atoms. And so my undergraduate work was at Imperial College in London, and I did physics, and then I went into astronomy. So then I've stayed in astronomy since then.
Okay, and you're obviously teaching as well now. You're based at the Arizona University, is that right? Sorry, the University of Arizona?
Yeah, in Tucson, Arizona. That's right. I've been here 30 years, in fact.
Wow. Okay. Okay. So, yeah, I mean, you've seen a whole shift in the whole space race, haven't you, right now? I mean, there's just been so much, and is so much change going on, and we'll get into that as well. Okay. Okay. So, where do we start with your work? Well, I will get into some of the more out there stuff, I think, just a bit later on in the interview. For yourself, then, for myself, let's just for anyone out there who's not too sure the difference between, right, even the basic science here, right? Let's just start with the basics, right? So we've got our solar system, we've got our galaxy. Just so I know, what is the difference between a galaxy and a solar system?
Right. So we got our solar system, which is the sun, and 8 planets. We've demoted Pluto. Astronomers have booted Pluto out of the set of planets. It's too small. It doesn't fit. So we've got a star of 8 planets, a lot of moons. I mean, the Earth has 1, but Jupiter and Saturn have dozens of moons. So there's a total of 100 moons or so. Then a bunch of rocky bits and pieces, asteroids, comets. And that's in one volume of space. And then the galaxy is a set of literally 100 billion or a couple 100 billion of those type of things, of solar systems, and that's all held together by gravity. So the galaxy is vastly larger than the solar system itself, and is made up of literally hundreds of billions of solar systems.
And how many galaxies then in the known universe do we think right now?
And then again, you're at a number like 100 billion, roughly, again, a couple of 100 billion galaxies in the universe, and the Milky Way is typical. So each of those galaxies has hundreds of billions of solar systems. So if you're asking, you know, how many planets in the universe, it's 100 billion times 100 billion, roughly, which is a simply vast number.
I mean, it's incomprehensible in one respect, isn't it?
Yeah, I mean, even for astronomers, even for people who do this every day, the number is sort of a little meaningless because it's so large.
Is that the thinking nowadays, that we potentially live in a finite or infinite universe?
So that 100 billion galaxies is not necessarily the edge of everything. That's simply as far as we can see with our telescopes. In fact, the universe in astronomy is bounded not by the fact that we see an edge, because we don't. I mean, there's no physical edge to space, which would raise tricky questions like, well, if there's an edge, what's outside the edge?
Right, yes.
So you finesse that, because essentially you run out of time rather than space. So when you look out in space, you look back in time. So astronomers are essentially looking back towards the Big Bang as they count these galaxies further and further out. And so in terms of physical space, there's no obvious limit, because there's just a limit to what we can see given how light traveled in 13.8 billion years. We're limited essentially by our light reach in the finite history of the universe. And astronomy, neither theory nor observation, says that's all there is. So that 100 billion galaxies is essentially a lower limit, because there could be a lot more out there.
Absolutely, and you're open to that as well. But as you said there, the idea of getting to the edge of something and what's beyond the edge, and you're saying it's incomprehensible to get to the edge, because it's just, as you say, you run out of, did you say time there, potentially? Yeah,
you're going back in time as you go out in space, so you eventually see back towards the Big Bang, and then it's opaque for a different reason, because the universe was hot and light couldn't travel in it. So it's just an operational limit to astronomy. It doesn't know everything, and astronomers have to recognize that.
What was, I mean, as a kid, you must have, or as you've got more into, climbed the ladder, with degrees and masters and PhDs, these questions must have gone inside your head somewhere along the line, and it's almost the idea of, well, what was there before all of this? How does nothing come from something? I mean,
right.
Yeah, is that?
And that's still up for grabs. It's not. Astronomers also have, decided they may not be able to answer that question. So the Big Bang model theory is just a description of the universe from a very hot, dense early state, 13.8 billion years ago, to its big, empty, cold state now, full of galaxies with big spaces in between. The theory, the Big Bang, doesn't actually talk about what caused it, nor what came before it. So essentially the theory is mute to that question. And it doesn't mean you can't ask the question. It's a legitimate, fair question to ask. People want to ask that question, but scientists can't answer it right now. And that's something people don't appreciate about science, that science is especially where I live in the US, it's become a bit of a football. People are bouncing it around and kicking it about climate change and about various issues. But scientists don't know everything, and they can't know everything, and scientists have to be a little humble about that and just say, well, sorry, we can't answer that question. We have some ideas, some theories, but not everything is knowable in science. And so this stereotype, sometimes in a negative way, of
Yes.
Science is omniscient and knows everything, and then they're know-it-alls and telling us how things are. Well, it's not really true, because in some things science has its limits, doesn't know, can ask the question but can't answer it. And then, as just an aside, of course, the people who do astronomy, and especially in high energy physics where you're probing the nature of matter, they are driven to ask those fundamental questions. So it's not like they're off the table, or they're fair game. And that's how you make your science better, by pushing the limits, the envelope, and maybe we can ask the question. There are people who have, are working at the limits of theory, who are trying to guess at a mechanism that causes a Big Bang, or whether there were other parallel universes. This is the multiverse idea. But it's very speculative. It gets into the popular culture as some cool science fiction idea, but it's not hard science yet, because there's no evidence for it.
No hard science for it, and I'll say that most definitely, well, along with yourself, absolutely not. But as you say, there's those physicists and cutting-edge people out there who are going more into imagination in some respects, but I suppose that's kind of imagination is where it sparks something, isn't it, to more than what we've got now,
Yeah.
maybe. And the idea of the multiverse, I mean, that's, we just talked about an infathomable, infinite universe there in the conversation, and we're talking about infathomable multiple versions of that layered upon each other, in a sense that, just as we are here now, there's something else that's occupying this space that the multiverse would be in as well. I mean, it makes, well, it's beyond our comprehension, isn't it? But as you say, it's okay. Well, they're delving into it, aren't they? I mean, even the holographic universe model as well. Some, physicists have, done books on that.
So there's been the nature of the speculation. It comes from this concordance or alignment between looking at the very large, the universe, and the very small, the nature of matter. So the people working on the fundamental nature of what particles are made of have come up with these multidimensional
Yes.
theories,
Yes.
theory and so on.
Mm-hmm.
And as soon as you put more than 3 dimensions of space and 1 of time on the table, then you obviously could have space-times that are beyond our own, that are invisible to us. And so it's not like our universe occupies everything, however you want to define that word. It's that there's more out there in higher dimensions, or and that's the nature of the parallelism between universes in the multiverse. They can be disjoint in terms of space-time.
Yes, and we'll keep this. We'll get back to groundedness with this interview in a minute, because you could say in one respect, well, what does that matter? But I think to not ask the question is just as I think to deny it and almost say, well, does it matter? Is a cause not to explore further sometimes. And I like the idea that you're quite open-minded to that, of the what if. It's not scientifically proven or nothing, but just, well, you know, there are colleagues obviously working on some of this stuff. Yeah.
Yeah, definitely. And
Yeah.
it's legitimate science. I mean, you ask questions, you take your existing theories and push them to the limit and maybe improve them. You make, hopefully you ask a question of nature that you can answer with an observation. That's science. If you're just speculating, fine, anyone can speculate, and you don't even need the training in the science necessarily.
No.
But so there's a fuzzy boundary between science and speculation that's important to occupy, because that's how you make progress.
Well, you think, you know, when the space race was first going on, what, 30 years ago? Well, was it 30 years ago now, the space race? Yeah, it was about that, wasn't it?
In sort of the 60s.
60s, yeah. You know,
the heart of the space is almost 50 years now.
50 across, yeah, right. What I'm talking about, yeah, exactly. And these questions would not have been asked. But I mean, just look at where we are nowadays with a, you know, private investment going into space travel as well, and everything else. I mean, these things were just not even dreamt up then, were they? In some respects, I mean, who would have thought we've got, you know, more private space explorations going on now than actual, you know, NASA's taken off in one sense.
Right.
So,
although the space game is a little, I mean, astronomy just moves forward with bigger telescopes, more space missions.
Yeah.
Pretty linear progress. The space program is a little more interesting because some people think, you know, we've been treading water for a while. I mean, it is, you know, over a half century since we went to the moon last. And so some people looking at it will say, well, it's not really got very far, has it? Because we went to the moon decades ago and we haven't been back. So how is it that we're doing better now than we were then? So some observers of the space program, you know, cross their arms and say, well, it's not that impressive, really. You're just struggling to go back to a place you've already been. And that, of course, misses all this new money on the table and all this new intellectual, entrepreneurial energy on the table, which is probably going to take us to some very interesting places.
I think so. I really do. I mean, you know, yeah. I mean, we use the Russians quite a bit now for our capsule launches, don't we, in one respect? I mean, we're not... I don't think America's got any functional takeoff facility.
America's been 6 years since America could put one of its astronauts in orbit without help from the Russians.
Isn't that crazy, isn't it? I mean, how do we end up there?
Well, I mean, so I suppose you have to get the historical view, because the space race, you know, the original one, the late 50s to mid 60s, that was a product, it was a post-Cold War geopolitical rivalry between the world's two superpowers at the time. That was kind of anomalous. That was a very peculiar historical origin to something. And now the space race is driven by different motives. There's still some geopolitical stuff, there's military stuff, but there's a lot more private industry and younger talent, you know, and so it's driven by something different now. So the second version of the space race, if you want to call it that, will look different from the first one.
Yeah, that's for sure. Now, just to let you know, all your books are just coming up on the screen as well periodically, and your website is?
It's just my name, chrisimpey.com.
Okay, well, we're putting that on the lower third as well throughout this interview. Okay, so many questions. Yeah, and with astronomy nowadays, I mean, why is astronomy important to us nowadays as well?
So astronomy, of course, is not important. You know, no, astronomers don't pretend it's vital to the national interest or economic growth or GDP. It isn't really. There are spin-offs. I mean, astronomers actually push technologies in ways that we may not appreciate. I'll just give one example. You know, the CCD, the charge-coupled, the little silicon chip that is in now 1.5 billion cell phones as everyone's camera and the sensor that we all take for granted, that actually started in research labs and was used initially for astronomy in the 1970s. And so all the bugs and the early R&D on the CCD that is in every one of our digital cameras and phone cameras started as a research device in astronomy, and astronomers were fussy and pushing it to the limit, and that improved that device. So occasionally astronomy has a spin-off like that, but generally it's what we would call curiosity-driven research. It's pure research. It doesn't have a societal benefit directly, except if you want to say, well, we're different from the apes and other animals, and we have concerns beyond feeding ourselves and putting clothes on our back. And then in that case, it fits in with delivering on the power of our brains.
Absolutely. Well, what drives you, Chris, to keep doing the work that you're doing as well?
I think it's part of what we already talked about, that even as astronomers have this more sophisticated model of the universe and the Big Bang, there are these huge questions we still can't answer. So it's not like you run out of questions like all the flavors chewed out of the gum. So with the universe, the two biggest ingredients of the universe are dark energy and dark matter. They're kind of mysterious, and physically we don't know what they are. So that's pretty basic ignorance to have in a mature subject. We don't, like I said, like we talked about, we don't know if the universe is truly finite beyond the areas we can see with our telescopes. We don't know if there are parallel universes. We don't know what caused the Big Bang. So I can quickly make a list of about 8 or 10 pretty basic questions we haven't answered, which means there's plenty to do still.
Absolutely. And to, the progression to try to, get even an infinitesimal amount closer to some of these answering some of these questions, that's got to be worth it in our lifetime. It really has, and for future generations as well. So that obviously you're teaching millennials, and I've had people on my show where they've talked about the moon being a hoax, and the moon landings being a hoax, and I wouldn't do those type of shows again. They gave their opinions, of what they stated and everything else. But you must hear this from the millennials, and actually there was a film called Interstellar that came out a few years ago, and that had the that going to the moon was just a conspiracy theory for the yeah. So you must experience this in at the uni with some people?
Sure. I mean, I teach introductory astronomy to freshmen, 18, 19-year-olds that not science majors. They're taking other subjects pretty much. And, they can be skeptical. They can ask these kind of questions. And I suppose the Gallup polls in the U.S. say that 8% of the American public don't think Apollo went to the moon, that they think it was a hoax. So I have a sort of binary reaction to that particular one. There are others. The educator in me gets a little annoyed because that's sort of being willfully ignorant of a lot of evidence. And you just have to contort yourself into a pretzel to hold a belief like that, given what we really know. We've been doing scientific experiments on the moon since Apollo. We have left little reflectors and magnetometers. We know the moon is getting further from us. We measure moonquakes every year. There's data coming back from the moon ever since Apollo. It's not just that we went there and came back and brought some rocks. Then there are all the 400 kilos of moon rocks. There's etc. So you can make a list. You can see the tracks of the rovers. You can see the landing module left. Yeah. So on the one hand, it gets me a little annoyed, and I address it in class, and I'll show the evidence of the moon just in case anyone's doubting. But then the flip side of that is, if I made a list of the batshit crazy things that 8% of Americans believe, like Elvis is still alive or the JFK conspiracy theories, then Apollo is just in that mix. And so why should I get particularly annoyed about Apollo hoax?
Well, we're getting. I mean, I've interviewed many people about the JFK assassination, and we're going to get into the whole thing about what types of life forms there might be out there. And I'm very open-minded myself, but I think that particular one just that we're discussing here, I don't exactly buy that. But then the question is, why have we not been back, and what would going back do for us?
Right. So that's a good question. What's to learn about the moon? What's the point of going back to the moon? We did it. It was very expensive. It was very difficult. So why go back? And the entrepreneurs, the Elon Musks of the world that are going to try and do it, and others, they answer that question a couple of ways. One, it's a way of testing technology and rockets to let them do other things, like mining asteroids, where there's definite economic benefit, or just exploring elsewhere in the solar system. So one is just developing their technology. Two is obviously tourism, recreation. There are several companies that have economic models. They're very high-end tourism, of course. The first space tourists a decade ago were paying $8 or $10 million just to go to the Soyuz for a week. We launched on the Russian vehicle, and there were only less than a dozen of them. It was a tiny number, but eventually it'll come down in price. You know, flying commercial aviation in the late 1920s existed. It was extremely expensive. Nobody did it. You'd have to be super rich, and so it's the same transition. So they do have an economic model, even to go to the moon. And then the third one is there is an economic potential there because the moon has resources. If you do want to do something like mine asteroids or do a big economic activity in the solar system, you need a base. And the moon is a very logical base because the gravity is weak. So if you set up a moon base, it's cheap in terms of rocket fuel and energy to go around the solar system or, you know, lasso an asteroid and bring it and mine it, or go to Mars or go elsewhere. So the moon is a very good staging ground, and that's why it's still of interest. And it's also close. I mean, the moon is a few days away on a rocket. Mars is 8 months away in a rocket. So much harder, much more expensive, much more difficult. So if you're really serious about leaving the Earth and being off Earth and having a new industry and economic activity, you do start with the moon. It's the sensible place to begin.
Do you think the man's body could take being on the moon for a long period? I mean, look at the degradation in the bone structure and everything else, just even on the International Space Station over prolonged periods.
Yeah, I think the jury's out on that. I mean, the space station, of course, is zero gravity, so that's worse. A sixth gravity on the moon is going to be hard. So I think that the medical research is a little, you know, it's discouraging because there's a lot of capillaries change, the eyeball changes, say there are various degenerations of bone, of course, we know that. So yeah, the costs of being long-term off Earth medically are quite significant. So I think for a while, for maybe a couple of decades, it'll be people doing it for a year or two. You know, you'll be swapping out colonists or swapping out people on these bases. They're not going to live and die there initially.
No.
And there's plenty of people that are willing to take the risk. I mean, there's plenty of people willing to take the risk of getting there. That's actually the more dangerous thing, is just the rocket and the travel. And there's plenty of people willing to take the risk of radiation and being in a strange environment and depressurization of your habitat. You know, if you ask people, they're going to do it. You know, they're willing to do it.
They are, and there's a lot more billionaires out there nowadays. So there's the money to do it. And doesn't Elon Musk, doesn't he want to die on Mars? Is that right?
He said that.
Yeah.
There was another telling statistic that didn't get commented on. As you recall, a couple of years ago, Virgin Galactic had a disaster. They had their test vehicle crash. The co-pilot was killed. The pilot nearly killed. So it was very bad. And they were thrown back. Their timeline was thrown back a couple of years on their sort of joyrides, their zero-gravity joyrides. Well, in the aftermath of that, Richard Branson very publicly offered, all these people put down deposits, as you probably know. Yes. Thousands of people put deposits down for the $250,000 joyride. He offered everyone back their deposit, no questions asked. And he got almost no takers. He got a handful of takers out of the thousands of people who put their deposits down, which told him and tells everyone, okay, these people, you could mock them and say, well, they're just, celebrities and people doing it for a lark and a joyride and so on. But no, they know it's risky, and they were still willing to keep their deposit in play.
Incredible, so again, isn't it? When is he actually going to start that tourist part of his business for space tourists?
Because of that accident, he had to go back to the drawing board on safety procedures and so on. I mean, the vehicle is fundamentally sound. There were just some operational things and some safety things. So it's sort of pushed off to late next year to have his first flights again. I think the actual taking fares from all the people on the wait list is 2019. So it's a couple of years away. It's not super far away, but it's longer than he wanted.
No, and I mean, when you think of the amount of people that have actually been in space, been into zero gravity, it can't be that many.
It's just under 600.
Wow. Okay, so it's
I mean, it's not a trivial number. It's 10 times less than the number of people who've stood on Mount Everest. So it's a pretty special club.
Very special.
Number of people who've been outside Earth gravity is 24. The Apollo astronauts, 12 stood on another world. That's a special club for sure.
Wait, and even getting to the moon as well. What about some of the conspiracy theory people? Just got to mention this right now. They talked about the radiation belts that lie out there as well. That how that would have, you know, damaged them. But then some of the others said, well, no, because they went through them so quickly, they just passed through them so quickly. It wasn't much damage to the human body. But
it's a significant dose of radiation. But what, for instance, they've worried about this for Mars, because to go to Mars is 8 months, you know, more than that week to the moon.
Yeah.
And basically, with the current spacecraft that the people would think of going to Mars with, in a trip to Mars and back, you take about 3 times your lifetime radiation dose on Earth just from that one trip.
Wow.
And you could say, well, that sounds terrible, but it's only 3 times. It ups your cancer risk by a few %. And so again, in the scheme of things, for people who are looking at the extraordinary lifetime, amazing adventure of it, upping your cancer risk a few %, oh, come on. You know, I mean, they're still going to do it. So it's just a matter of it's a matter of perspective. The radiation risk is significant, and it does go up. And you do travel out of the Earth's protective blanket. But, you know, it's probably small compared to the risk of the rocket blowing up or the spacesuit pressurizing or all those other things that could happen.
Well, if you had a chance, would you go and do the zero gravity with the Virgin Galactic?
Oh, I'd do that, and I'd go. I'm not in the must camp. I don't want to die on Mars. I've got kids,
Yes.
family, and friends. I've got plans for when I retire, so I'm not quite in his category. But for sure, I would love to go into space. I had there's a thing called Space Fest here, which is a gathering that moves around the western region of space enthusiasts and amateur astronomers, and you know, they sell meteorites, all that stuff. And they do gather astronauts for these things. And one year, a couple of years ago, they had all the moonwalkers.
Wow.
And that, you know, again, you're talking about a special club. So there were 12 men who stood on the moon, walked on the moon, and at that time, 2 had died already, and Neil Armstrong, who subsequently died, doesn't do that. He's the only one of the moonwalkers that's was very private and didn't do public events. And they had all the other 9. And there was this photo op, and people were just, you know, all these space enthusiasts, of course, were gaga because,
I bet they were.
wow, this is, you know, that is the most special club on Earth, the 12 men or people who stood on the moon. And here were all of them, essentially, in one room, who'd seen something that no one else can see, and nobody's seen for a half century as well. It's not just they had a special experience. Nobody's repeated it.
Well, some of them, it's such a special experience to them. And look at Edgar Mitchell. I mean, when he came back home, he totally devoted his life to the exploration of consciousness.
Yeah, that's right. And I actually was at the table at the same event. I was at a table with one of the moonwalkers, the one who did the psychic and ESP experiments in orbit. And it was NASA. It was a little embarrassing for NASA because he was into this and doing this, and they didn't really sign off on it. But it's been his interest ever since as well.
Yeah, he said. I knew someone that interviewed Edgar Mitchell. I was the producer for the show when he interviewed him, so I'd put Edgar through to the host and all that kind of stuff. And yeah, when he was explaining that Kundalini that he had, looking back at the Earth, it just changed his whole perspective on what he thought this nature of reality was. It really did, and
right.
I can imagine it would do that. I can imagine it would do seeing that. I mean, it's just, well, I can't imagine what it would be like, but I mean, I can imagine it's so life changing. You know,
and some people have criticized NASA for not being very imaginative in their choice of astronauts. I mean, you know, they were, of course, all test pilots and military people early on. Then they broadened into scientists, and then unfortunately, they tried to send a teacher, and that woman died, of course, in the shuttle. So they got scared, essentially, of sending civilians into space. And that's a bit of a shame, because if you send artists and philosophers and musicians and poets into orbit, their experience that they can transmit to everyone else and convey to everyone else is very different. I mean, the type of engineer, test pilot, military personality that goes into space is not usually very effusive or the kind of person who will be evocative. Edgar Mitchell is probably an exception.
Yes, he's an exception. Yeah. Yeah, I think. Well, yeah. I mean, I mean, isn't it amazing that we've got we can now anywhere in the world we can now watch NASA TV. It's not just in the USA anymore. You can go online to YouTube, and now NASA's streaming 24/7 on its TV channel now on YouTube, and I think times are changing, aren't they? I mean, I mean, let's just look at the International Space Station, for example, right? I mean, the money that cost to get it to where it is now, and a lot of the companies that promised that they were going to be part of it or do the experiments have faded and gone into time. It's now more of a publicly funded, but U.S. government. Well, it was an international effort, of course, to get it there. But what is the future of the space station, would you say, as well, right now?
I think it's it's up in the air, so to speak.
Yeah.
It's I think the price tag as we speak is about $120 billion and counting. It's expensive. 16 really countries expensive. Involved.
Yeah.
And a lot of scientists, a lot of my tribe, are not very keen on it because they think it was oversold. I mean, astronomers don't want to put telescopes on it. It's not a very good research station. Drug companies have not flocked to use it to do pharmaceutical research, except if it's enormously subsidized. So it's seen as a bit of a white elephant, even by the space science community. I guess the flip side of that, and maybe it's not enough of a flip side for that price tag, is that it was a demonstration that we could live and work in space. And it's been continuously inhabited for a decade or more.
I know,
and it's very international. It's an example of international cooperation, even though the Europeans and Americans are not very pally with the Russians. There are Russian and American and European cosmonauts up there all the time, doing just fine.
Yes.
So it's an example of international cooperation. But it's a little mundane after this amount of time. People forget that most of what happens there is sort of electrical and plumbing work. I mean, it's sort of...
Yeah, that's so true. Yeah, no, that's so true. It is a bit mundane because... I mean, any time I can get to jump on to watch the NASA channel, I'll watch it, right? But it's very much an American thing right now, the space race in that sense. And it's like, well, how did we get to that point? How do we allow it to get to that point? And that's sad. That is, when us Brits travel to America, and some people say, "Oh, did you go see the Kennedys? Where is it? The famous place in America? I'm trying to tell you about it, but
Center,
yeah, that's it. Sorry, the Kennedy Space Center. Yeah, and it's like we just don't have that over here, nor does anywhere else in Europe or any other place. And it's like, well, it was an American thing at one point, and still is.
It's primarily American, but it's actually very international. I mean, it's like I said, 16 countries at any given time. If you ask who's on the space station, it'll be an international group. It's never all Americans. But I agree, it's not really panned out the way people thought. Once you've demonstrated you can do it. Now, the wild card, of course, there are two wild cards. First of all, the private sector is going to step in, and so I think eventually there'll be a private space station for tourism. There's this guy called Robert Bigelow, one of the billionaires. We alluded to billionaires doing this, like Branson and Musk. Well, another one is Robert Bigelow. He founded the Motel 8 chain in the U.S. Everywhere, in every city you go, there are these motels. And he's had NASA contracts to do these inflatable hotel habitats, and he's tested them attached to the space station, but they've done very well. They're very viable. So he's fully planning to do sort of space tourism, space hotels with his own technology. So that's one. Then the other that's a little more ominous is the Chinese have plans for a space station. And that gets people very nervous because in China, the twinning of the military enterprise and the government enterprise is tight and very secretive. And so people worry about nukes in space. And I think it's a fair concern. So the Chinese are planning a space station of their own in a couple of years, and that will make people nervous.
I mean, that's just incredible, isn't it? Just to even think that that's even being talked about right now. That's right. Yes, it will make people nervous. Isn't there some treaty in space, I believe, that unless I've got it wrong, there's no laws or ownership in space. Yeah.
So you're right. There have been 2 UN. I mean, the trouble is how enforceable is any of this? But yes, there have been 2 UN treaties that relate to space. So there was the Outer Space Treaty of 1965, and that's the really important one because that bans nukes in space. That sort of demilitarizes Earth orbit and beyond. And luckily, all like 170 countries, including the big powers, have signed it. There are a few rogue states like, Iran, Afghanistan, North Korea that never signed it, but all the ones who can do space have signed it. That's good. So that's the bulwark against the Chinese. The Chinese will get a space station. They're going to do it. The bulwark against it being militarized is that they signed that treaty, if we trust that. The one that and then the other one is important that you're alluding to. There was a Moon Treaty of 1979, and that was the one that was supposed to deal with ownership. Who owns, who owns the Moon? Who owns Mars? Who owns asteroids? And that treaty didn't really it tried to address that issue, but nobody signed it. The big powers never signed the Moon Treaty. And so the truth is, it's a Wild West. Anyone could, you can go to the moon. You could, NASA is nervous that some private entity will go to the moon and make a theme park out of the Apollo landing site. And they can do that, because there's no legal jurisdiction to stop them.
Wouldn't that be absolutely insane to see 100 years from now, just where we're at? Oh my gosh, a theme park, yeah, in space. Well, again, I mean, there's so many satellites in space right now. There's so many things orbiting, experiments of all sorts, because it's easier now to send out remote probes and robotics rather than humans out there, isn't it? Really.
And that's sort of one of the innovations in space that's not noticed by so many people, the miniaturization part. So the same technology that's in your cell phone, sensors, cameras, GPS, all that stuff, you can put that into orbit now. So people are taking, postage stamp sized little packages of electronics and sensors and batteries and so on. And you can now launch a satellite that's, the size of a Rubik's Cube. And they're actually called CubeSats. That's a standard technology. And for this price of, $10,000 or something. So student groups do this, single universities, entrepreneurs, individuals, not super rich people. You can put a little satellite package together, and then a bunch of people just put all their Rubik's Cube satellites together. You launch 100 at a time. It doesn't cost that much. And you're doing space research. So that is brand new. That's all in the last few years.
It's almost like it's going to be like Blade Runner in the future, where there's, all the advertisements going to come from near Earth orbit, projected down.
Well, now you've hit on a sore spot for astronomers. So astronomers like dark sky. And as we've said, with the lack of any commercial restrictions on the space activity, astronomers freak out that some company like Coca-Cola or whatever is going to go up and put a huge huge sign in space and mess up the dark skies that astronomers depend on. And that could happen. I mean, there's no law against it.
So anyone could go, if they've got the means to launch. No government's going to stop them from launching, and we can actually put something into space. That's what we're saying. Even on low Earth orbit, there's no laws to say. That's crazy, isn't it?
There's rules about, as you recall, the Chinese took a lot of flack when they blew up one of their own satellites and created a lot of space debris 5 or 6 years ago. But even then, they weren't violating any international law. That was just really bad behavior.
That's like that movie, isn't it? The movie. What's it called with George Clooney and everything starts impacting one another, doesn't it? It was a famous. Yeah. What movie was that called? Yeah,
I know the one. I'm losing the title too.
I'll put it on the screen.
There's very little regulation on the space activity. Basically, it is a wild.
Is space junk a real problem then, in one sense? Oh yeah,
it's a real problem because it only goes in one direction. I mean, people just toss up satellites, and the truth is, space is not super crowded. I mean, if you were up there floating around, you're not going to be bumping into things. But impacts are super dangerous because the speeds are thousands of miles an hour, typically, if you could get hit. So a little grain of sand type particle could puncture a hole in a spacesuit or a spacecraft. So collisions of even tiny things are damaging. And then the truth is it just goes in one direction. Spacecraft degrade. If they do collide, they break into shrapnel, and that shrapnel just stays there. Some of it eventually deorbits. So eventually there's enough drag with the tiny, slender amount of atmosphere there is that it sort of falls down.
Right.
But but that debris is not emptying out by that mechanism at the rate it's being added to by new satellites.
I got you.
So it's a problem. So people who have really valuable hardware, like the Hubble Space Telescope, good example,
Of course.
they want it in a higher Earth orbit. They want it 300 miles up rather than 100 miles up because, you know, you've got to get above where all the satellites are.
It's like that. There was the film The Fifth Element, and you see them going into Earth's atmosphere in the future, and there was just so many satellites, so much mess there was, and yeah, I suppose. Do you think it will ever be policed in one sense, or ever be, you know, because when you launch something, yeah. Sorry, go ahead.
It's too. I think it's almost too late now.
Too late. Yeah.
You'd need some international. You need again a UN treaty of some kind that everyone would sign, and that horse has left the barn. I mean, it's probably not going to happen.
Right.
Now, if there was really bad behavior, you know, if some megalomaniac billionaire industrialist went up into orbit and started, you know, destroying other people's property and so on, yeah, it would get policed. But I think it's going to take really extreme behavior by a government or an individual before anyone gets agitated enough to do anything.
Well, what do you think about secret space programs run by covert agencies in the US government or international governments? Do you think that's going on at all in some respects?
There are secretive programs. I mean, on the US side, it's pretty well known that because the space shuttle was a bit of a, you know, was an unreliable vehicle, 2 out of the 5 orbiters were lost catastrophically. So the military in the U.S. bailed out on the space shuttle decades ago or so, and they have space planes. So the U.S. military is developing their own space plane, sort of air-breathing at low altitude, rocket at high altitude. And they have a pretty advanced model, so they're doing their own thing. The Chinese is definitely secretive and very advanced, so their number of launches, of just orbital launches, is up at 15 a year now. And like I said, they're planning a space station, they're planning a moon base, they're planning all sorts of things that are very ambitious, very expensive. But of course, the difference is NASA's budget is flat or declining for the last few decades. In China, the economy's been growing 8 or 10% a year until recently, and their space program growing at that rate, which doubles every 5 years. So you can do the math, and they can buy quite a lot of
major money. Yeah, absolutely. Yeah, a much bigger budgets than NASA. Totally. Thank you for that as well. We're almost at the end of this interview because I'm cautious that you've got to get going very soon as well. So let's get to the defining questions. Are we alone? Rather than just bacterial life out there, or, you know, some nano form of life, is there anything in your gut that tells you that there may be something equivalent to us out there, conscious in a sense?
Right. So it's a good question because it comes back to where we started, the real estate in the universe.
Right.
So the math, the astronomers don't know. So the simple answer is we don't know. But the likelihood is high just because of all the real estate. So if we said there's a few 100 billion planetary systems in the Milky Way, the astronomers now have a pretty good number on the number of habitable Earth-like planets in the Milky Way, in our galaxy. It's 10 billion or so, 10, maybe 20 billion. And then there are all those other galaxies. So you can always just multiply 10 or 20 billion by 100 billion for the universe. But just in our galaxy, 10 or 20 billion. So you're going to have to say that those are all places where life could be, where the temperature's right for water, where there's energy, where there's an atmosphere to shelter you. Earth-like, not totally identical, but similar. You're going to have to say that on none of those, not only did biology start, and you've got microbes, but on none of them did it develop into anything advanced and intelligent with technology. And while it's possible that those 20 billion biological experiments either all didn't happen, you know, they just ended up inert, or none of them progressed beyond microbes, I think it's pretty unlikely. So most astronomers, if you ask them, would say, yeah, it's probably likely there's advanced life out there. Now, that wouldn't have to be just like us because, you know, think about it. We can't communicate with creatures that share 99% of our DNA, apes. And then you've got dolphins and elephants and other fairly intelligent, possibly sentient creatures on the Earth that we can't have a dialogue with. We don't have culture to share with them. And they're on our planet. So once you've imagined a different form of life on another Earth-like planet, it could be very different. So the communication issue, astronomers like to very strongly distinguish the likelihood that intelligent life exists of some form and the fact that we could have kinship or communication or any dialogue with them. that's much less likely.
Unless it's from one of those interdimensional universes.
Right. Okay. And what's happening in the multiverse, we don't even have a clue.
Exactly. So do you think man's destined to leave planet Earth and travel the stars? I mean, Nostradamus, didn't he predicted that man would leave this planet one day and that it would go off and find a new home somewhere else? I mean, do you think we're destined to do that?
I think it's in our genes. I mean, I think the exploratory instinct, which took us from Africa, and really other animals move around the world and migrate, and there are birds and other animals migrate huge distances for food, and it's a fixed pattern. Humans are the only species that migrated when we were just hunter-gatherers all around the world, almost to every place. I mean, to crazy places. Yeah. Very quickly. So I think it's built into us to explore, and when we can explore off the planet, we'll do that. So I think we'll do it. I mean, I'm hoping that we won't do it because we have to, because we've messed up the Earth so badly. We need a new place to go. Yeah. I think that would be the bad reason we have to leave the Earth. The good reason is because we're curious and we're explorers, and some fraction of us will want to do that.
Well, I always say, is space ready for religion? I just don't know. And that's what we would be taking out there if we went. What would you say is the most important message of your work then, Chris?
Well, in the sense of that I do cosmology in my research, just for people to have a comprehension of pretty much the numbers we started with, and even the one we finished with, that you've got 10 billion, this is hard astronomical data now, projected to the universe. 10 billion times 100 billion is, I can't do the numbers, it's 1 with 21 zeros after it. That's the number of habitable planets in the universe. And that's an incredible number to come from science. And then you can just let your imagination do the rest. What do you think has happened on those 100 billion, 1,000 billion habitable planets? Yeah. And that's worth spending some time thinking about. To answer the question and inspect them and diagnose whether there's life. That's unfortunately a very hard thing to do.
Of course.
Astronomers are working on that. The space travel is brutal because stars are hundreds of thousands of times further away than the nearest planet. So answering the question scientifically is going to be hard, but it's on the table. It's on the table for discussion.
That's good, man. That's good. Well, listen, I really, I know we've scratched the surface of your work. I know we really have. And 51 minutes has just disappeared. I highly recommend your books. They've been coming up on the screen throughout this interview. They are really, even just for those that have just wanted to dip their toes into this subject, they're great books just for that. They really are. And they go deep as well in some respects. Well, in a lot of respects. So I just want to say, Chris, just thank you so much for what you're doing. And it's been a real pleasure to have you on the show.
Thanks, Kevin. It was a pleasure for me too. Yes. Thanks very much.
Well, we've come to an end on today's show. Don't forget that you can listen and watch all our past interviews on the More Show's official YouTube channel. Remember to subscribe to our YouTube channel for new daily shows. You may also find out more on all past and upcoming guests by going to themoreshow.com, and do like us on Facebook and Twitter for the latest updates. So until next time, be safe.